Welcome back, everybody. Today we're going deep on AI processors. Those tiny chips that make everything from our phones to self-driving cars work? And get this, we're exploring it all through the lens of The Wizard of
The
Oz.
Wizard of Oz.
Yep. A listener is writing a book on AI and uses this classic story to break down these complex concepts. Pretty cool, right?
That's definitely unique. I've never seen anyone use The Wizard of Oz to explain things like CPUs, GPUs, NPUs, and TPUs. I'm really curious to see how it works.
Me too. So just to get us all on the same page, CPU stands for Central Processing Unit, GPU is Graphics Processing Unit, then we've got NPU for Neural Processing Unit, and TPU for Tensor Processing Unit.
Okay, got it.
Now imagine Dorothy. She's our CPU setting off on the yellow brick road, which is like our path to advanced computing.
I see where this is going. Dorothy as the CPU makes sense.
Mm-hmm.
She's like the brain of the operation.
Maybe.
Just like she leads her companions, the CPU directs and coordinates all the tasks inside a computer system. Make sure everything runs smoothly.
Exactly. So Dorothy, the CPU, is leading the way, but of course she's not alone. Enter Scarecrow, who represents the GPU, known for processing visual information like a scarecrow surveying the fields.
Right. And the source material even mentions how Scarecrow can multiply and break down data for visual processing.
Mm-hmm.
That's highlighting the GPU's strength, which is parallel processing.
Yeah.
It's like this, the CPU is like one really smart worker tackling one job at a time. But a GPU is like a whole team of workers, each handling a smaller part of a bigger task all at the same time.
So they get things done faster.
Much faster. And that's why GPUs are so powerful for things like image recognition and machine learning, where you have huge amounts of visual data to deal with.
Okay, so CPUs are the brains and GPUs are the visual powerhouses. What about the tasks that need a different kind of intelligence, a more specialized approach? That's where the Tin Man comes in, representing the NPU.
Ah, the Tin Man. Perfect choice. He's just like an NPU. Incredibly efficient and specialized. They're designed specifically for neural networks, which are basically the backbone of many AI applications.
And the book points out how the Tin Man can turn his heart's power down to save energy. A clever way to show how NPUs are all about efficiency, especially in things like smartphones, where battery life is so important.
Exactly. That efficiency is what makes NPUs perfect for mobile devices and anything that needs AI power without draining the battery. But don't be fooled by their efficiency. They're still super powerful, especially when it comes to things like natural language processing and object recognition.
So we've got Dorothy, the CPU, Scarecrow, the GPU, and Tin Man, the NPU. Who are we missing?
Well, we can't forget about the Lion. He's our TPU strong and ready to handle those big machine learning tasks that would make other processors sweat.
That makes sense. TPUs are built to deal with the massive demands of training and running those complex AI models.
Exactly. Think of TPUs as the heavy lifters in the AI world.
Right.
They're all about speeding up the training process for those large, complex models that power things like language translation, generating images, and even self-driving cars.
Wow. So we've got our whole AI dream team assembled: Dorothy the CPU, calling the shots, Scarecrow the GPU, mastering the visuals, Tin Man the NPU, handling those neural networks, and Lion the TPU, powering through the big machine learning challenges.
It's amazing, isn't it, how this simple analogy from The Wizard of Oz can make these complex technologies so much easier to understand.
It really is. And it shows us that even though each of these processors has its own specialty, their true strength comes from working together. That's how they create powerful and sophisticated AI systems. So we've seen how the Wizard of Oz crew maps onto these different AI processors. But how does this actually play out in the real world? Like in self-driving cars, for example.
Perfect example.
Yeah.
Imagine a self-driving car navigating through a busy city. Just like Dorothy leading the way, you've got the CPU at the helm making those high-level decisions, constantly monitoring all the car systems, analyzing data from the sensors, and making sure everything is running smoothly.
Keeping everything in check.
Exactly. And while the CPU is directing traffic Scarecrow, our GPU is focused on the visual world, processing all those real-time video feeds from the car's cameras, identifying pedestrians, other cars, traffic lights, all those visual cues that are crucial for safe driving.
So the GPU is like the eyes of the car?
Exactly. And its parallel processing power is key here. It can analyze all that visual information in an instant, so the car can react quickly to anything that happens on the road. Pretty amazing.
Yeah, that's a lot of data to process. But navigating a city isn't just about seeing what's around you. It's also about making those split-second decisions that keep everyone safe. That's where the Tin Man, our NPU, comes in.
Right. The NPU is using data from all the car's sensors, things like radar, LiDAR, ultrasonic sensors, to create a detailed map of everything around the car. It's using that information to make real-time decisions about steering, braking, accelerating, all while staying in its lane and avoiding any collisions.
So the NPU is like the car's reflexes.
Exactly. Always making those tiny adjustments to keep everything running smoothly and safely. And then working behind the scenes, we have the Lion, our TPU, constantly learning and adapting.
Oh yes, the TPU, the brains of the operation.
You could say that. The TPU is usually in the cloud processing massive amounts of data from all those self-driving cars out on the road. And it uses that data to train and refine the car's AI models so they get smarter and more efficient over time.
So the TPU is like the coach constantly helping the car improve its skills.
Exactly. It's a continuous learning cycle. The TPU learns from every trip, every bit of data, improving the car's ability to perceive, understand, and navigate its environment.
That's incredible. And the same interplay of processors is happening in so many other applications too, from medical diagnosis to financial modeling to even creating art and music.
It's everywhere.
Yeah.
And it's only going to become more prevalent as AI continues to evolve.
It's amazing to think that a children's story, like The Wizard of Oz, can help us understand these complex technologies. And it shows that while each processor has its own strengths, their real power comes from working together.
It's like a team effort, right? Each one playing a crucial role in the overall success of the AI system. And it highlights that there isn't one best processor for AI. It's about finding the right tool for the job and knowing how to combine those tools to achieve something incredible.
So to sum it up, our deep dive into AI processors has shown us that CPUs are the brains, GPUs are the visual masters, NPUs are the efficient specialists, and TPUs are the heavy lifters.
And just like Dorothy and her friends needed each other to make it down the yellow brick road, these processors depend on each other to power the amazing AI systems that are shaping our world.
It really is remarkable how this simple analogy from The Wizard of Oz makes these complex technologies so much easier to grasp.
It really does. It's a reminder that even though AI can seem intimidating, the basic ideas behind it are often surprisingly relatable. It's all about finding those connections and making the complex understandable. And on that note, we'll wrap up this deep dive. Until next time, keep those brains buzzing.
We've come a long way down the yellow brick road of AI processors. We met Dorothy, the CPU scarecrow, the GPU Tin Man, the NPU, and Lion, the TPU. But now that we've reached the Emerald City of Understanding, what does it all mean for us?
Well, it's about empowerment, I think. Now, when you hear about all these new AI advancements, you can picture those characters, and it can help you understand the technology better. Like if you hear about a smartphone with a faster NPU or a breakthrough in research using TPUs, you'll have a framework for understanding what it all means.
Yeah, it's not just about knowing the acronyms anymore. It's about really understanding what each processor can do and how they all fit into this big picture of AI.
Right. And that understanding is so important, especially as AI becomes more and more integrated into our lives. It helps us make better decisions about the technology we use, advocate for responsible AI development, and maybe even explore career opportunities in this field that's growing so quickly.
This whole Wizard of Oz analogy has been so insightful. It could have been a really dry, technical deep dive, but it turned out to be a fun and memorable way to learn about this stuff.
I agree. It shows how powerful creative thinking can be. Even complex concepts can be made accessible if you use the right kind of story.
It reminds us to stay curious, too, and be open to new ways of learning, no matter what the subject is.
Definitely. As we keep exploring this exciting world of AI, let's keep asking questions, looking for new ideas, and maybe even finding more of these unexpected analogies to guide us. Who knows what other hidden connections are out there?
And on that note, we'll wrap up this deep dive. Until next time, keep those brains buzzing.